which is organized by Huawei, and where we implemented a system for offensive content detection, and we came up second, and we're just going to talk about that system. So why I call it Think Simple, these slides? Because we were given 48 hours, and we have to come up with a solution. Data, we have to collect data, we have to make a system, we have to present everything. So we have to think simple and implement. But the main topic was deep learning. So with now deep learning, we all think like, how can we complicate the system? So now I try to find out how we can convert our thinking in a very simpler way, only to focus towards the problem, not towards the technology. So that was the challenge, which was sponsored by Huawei and organized by Launchpad. So we were a team of two, and what we try to do is stop social bullying, cyberbullying. So when we thought about that, yeah, right now, what's the situation like? We get cyberbullied in different sections. We try to find out how we can collect data which actually are bullied. So since I'm working on sarcasm, so I feel like, yeah, that's really something closer. So I can go on this and try to see if I can do cyberbullying. So then we team up, we try to collect data. First, we had a data set which was given to me from Trinity College, from our ADAPT Research Center, which was like 119K. Then we try to find out all of the resources. There was like a hate speech data set, there was an offensive content data set, there are many data sets we collected those, and we decided, okay, we're gonna stick to social media. So when we also have to find out if the problem is really big. We find out this was actually a stat from 2016 that 5 out of 10 adolescents actually are bullied online, and 1 out of 10 parents actually know about them. So right now in social media, we are still in an age, all of the next generation has social media, but not all of the previous generation has social media. So they don't know what's happening there. And if I ask my father, oh, go to social media and open an account, he's like, I don't care about it. So it's gonna pass by. So, but still, right now, how we can make a system which can go on where you don't need to create any Twitter account or any social media account, but you can still monitor your problem, the cyberbullying of your children. So that was the main intention, and that's where we started. So that's the chart we took from Wikipedia. Here you can see that actually in social media we find out there's another chart we find out that mostly it happens with the teenager, like age of 12 to age of 24, that's the range. And they mostly use Facebook and Instagram, that's the high amount. And that's where actually they get so much bullied. But since we were in a 40-hour competition, and I've always worked with Twitter, so I stick with Twitter. Twitter also still have a lot of cyberbullying which we find out. Now, in terms of cyberbullying, is it only children who get cyberbullied, or is it the children who bullies other children? No. We have Trump who bullied a handicapped reporter. There was Brad Hooker, this sort of tweets you can find a lot of tweets out there. So these are also offensive language is also are getting bullied, not only by the teenager or young people. So there's a phrase I know, charity begins at home. And that's true. That's why we got bullied by Donald Trump and his wife that we started the first cyberbullying. But still, she got bullied. So then we find out, okay, let's do one thing. Let's fight fire with fire. How we can do it? So we tried to bring dark weather. So actually I joined there just for fun. So I was like, okay, let's make add Skywalker, a bad guy, to fight with the bad guy. with the bully. So what we did, we went to the Twitter, we tried to create a system where if somebody tweets to someone, it is instantly bullied. So it will go back, it will raise an alarm to the parents that your son or your daughter is getting bullied multiple times. And also, we find out that when a person gets bullied, they have a mental drawback, like mental upset, and they are tend to suicide. So 1 out of 10 actually commit suicide. So that means we also need to find out what's the mental status also. So then we started looking for emotion database. We find out an emotion database, and then you find out, yeah, now I can actually create from their previous tweets, I can actually create their mental state. So if they're getting bullied multiple times, I can trace what's their mental status. If they're getting really sad, that should be alarm to the parents. So that's where the little guy comes here, and he says there is no escape. So he's always gonna report. So that's the troopers. So there is 3 data sets we find out, what is 117,000 tweets, there is a 5,009, that's a hate speed, and there's an emotion detection, which was near about 30K tweets. And there were 6 classes. So far it's fine. We have set the problem. Now comes deep learning. Now, deep learning right now is like a complex. So we all try to dig what's happening inside, and we want to find out what's happening inside. But we always go away from our own idea. What's the main idea? We go away from there. So if we think about 2 deep learning models, which is CNN and RNN, these are 2. So the first one is mostly used in image, video, or audio. And in that case, we can find out that those actually are hierarchical structure, they have a strong local correlation, or the features can vary anywhere. So like for image classification, if you want to classify cat, so anywhere the cat picture is there, CNN works better because it can find out. It doesn't matter where its location. For RNN, it's actually a sequential data, so that's why there is a text and times is work really well. But again, we are in hackathon. We have to make a system which is fast. I cannot have too much time to train an RNN. So, but there's nothing. So far, I try to find out where I can have a classifier which can use the CNN as a text. So then I try to find out this model, which is sentiment analysis system. And I find out they actually take the words, add the dimensions, and then they started doing 1D convolution over the data set, and they create a feature vector. Now, in image, every data point is continuous. So from one point to another point, it's all continuous space. But for word, it's discrete. So that's why we have word to vec, or we can learn our own ways. So I find out, okay, now we can do the convolution of 2 words together, which is more like an n-gram system. So I started doing that. And then I find out that when you have 30 words, I choose the length 30. And I choose the embedding length 1.2. And I initialize with random. And I find out the depth is 1. So it's consider this as a 1 tile. So if you have 3 tiles and you combine them together, you start to have a depth. Because why? You have 30 words. It's kind of like, okay, it's changed here. So it's actually the first column is W0, the last column is W0. So when you have 3 words, you combine them, that becomes only 1 word, but it starts to have depth here. So I find out, yeah, that's kind of like when I have, I, it has a dimension, but I has a more meaning than combine. So that's why I started to change the convolution, and I find out that first I did a 3 row wide and 5 column wide convolution, I did 2 times, this was in 2028. I added the tape 64, then I added the tape 128. But then there's a problem of overfitting. How we can solve it? There is comes max pooling. So I just added the max pooling, so I just space out which are the most important features and bring it up. So to that point, it makes sense. But if I consider in the text level which dimension I should pick up, which is the important dimensions, I don't know what's happening inside. So it's still kind of, we are lost in this deep learning situation. So we're gonna go there before I progress there. So we find out the results. Well, pretty good, really, really good. So like 92% accuracy in offensive content, like it's 119,000. We split by 80-20, and we got the results. And then head speech, good. Even 6-class classification, that also got good results. Then, does it mean that we solved text by CNN? Is it solvable? We're going to come to that question again later on. I have that. But now I come to the interface. So we just make a simple interface where we just put the ID, and it will give you who, where, what are the tweets you are getting, and what are the tweets you are saying. So what are the tweets you are saying says your mental mode. What are the tweets you are getting is how much hate you are getting. So it's just my colleague, the person who Martin sent it to me. So he just trained that on Donald Trump today. So it's not really great interface. We are modifying it right now, but you can see that at that moment, Donald Trump was, whatever he was saying, 48% was joy. But there are still, fear is there 16.6%. So you can find out what's the mental mood at that point Donald Trump had. At the bottom, you can see how much hate he's getting, how much offensive language getting. Hate and offensive language, there is a slight difference of data we find out. That hate is more serious case, and where offensive is not that much. So that's why we combine them by just 1 and 1.5 weight factor we added, and we calculated hate and offense when it comes together. What's the point? But later on, we want to include that as a timeline, like how your hate is going versus what's the mental mood is changing. That's what we want to plug later on. So the features was right now, what we created is allowing the parent to monitor. So you just type the account and you get all of the results. And also you can get not only your children's mentality, but also who is sending tweets to your children, their mental mood. So if you find out somebody is angry and your children is sitting sad and there's a hate tweet coming on, that's where you have to be alarmed. So that's what we are progressing later on. Now we are improving our UI to find out that the user will just go there, type it, and find out if it's actually it should be monitored or not, it should be taken care of or not. Afterwards, then we also find out hate. Now hate is also something which right now there's a blue whale. I don't know if many of you have heard about it or not. The blue whale is something, the social media game, where they ask to do something, and at the end, the 58th stage, they ask to suicide. So they manipulate. There are some hate speech, there is some offensive language. They ask people to do something. So if somebody is also throwing away hate language, then you can also monitor. So you actually can monitor the mental health of your child, mental health of your surroundings, and what he is talking about, without letting him know. Because you don't need his user ID password. You just know what he's throwing away in the public. Now, since it's PyData, so I just created this is my GitHub, where so I generally use Keras because I try to stay within the problem. Not like it's like a really easy to write any code, and I try to create a structured code. So where you can see that I'll show you a little brief of the data, how you can store the data. So it's like a first identifier, then you keep the label, and then you keep the text. If you keep the input format in this tabular format, and then you can easily change your model and it will run. So to create the model, it's just here I have a build model function where you just change that part to create the model, and the rest, and you give the what to wake path, or you don't want to use what to wake path, you want to train your own weights, all can be done by just if you give the what to wake path, it will learn the what to wake path with the what to wake. You can freeze the what to wake. So that's all flexibility I have written in the code, which you can find out in this one. The links will be shared, and it's also, if you click, it just goes there. And for the data set, here is the train, test, and development, and the text model actually stores all the models. So in the train, I think, yeah. So there is no small one. So I would say just later on check. It's just a 3 column. The first column is just identifier. Second column is a label. Third column is the text. That's what you have to put, and you can train the system. I think I need some help with the math. Okay. Yeah, I think. Yeah. So now we are all mathematics. Whenever we solve a problem, we're computer scientists. Whenever we have a problem solved, we need another problem, which is harder, which has to be harder. So now I'm gonna do a rollback. Because I started with sarcasm detection, and there I created a system. And then I find out I created a complex model. But when I when I won the second prize of the hackathon, I actually make a really, really small model, just like CNN. So that means I asked the question, does CNN can solve all the text problems? No, I would not say no. Because I tried the same model on my trained data set. I have 51K sarcasm data set, development set, and a test set. No, it didn't go well. My system, which you also can find out in my GitHub, this sarcasm data set is also posted. The code is also available. I tried that, I got 91. So how I went there? There comes the solution is here. So when you find a text, that's my rough estimation right now I got. So when you find a text where you can clearly see the textual feature is present within the text, not too much depth, then you can actually go for CNN. It's a faster training, you can get a good result. But if the problem is really hard, like really pragmatic, where you need to know the sequence of the entire text to understand it's sarcastic or not, then you must go for RNN. Then the time to spend on RNN will pay well. I have the system. What I did, how I actually measured this. First, I have the word to wake, I freeze the word to wake. I just train with CNN. I see how much CNN can pick up. I drop the CNN. Then I just added only 2 LSTM. I find out how much LSTM can pick up. I dropped everything, and I just added DNN, deep neural network, all fully connected network, and train it. And I find out how much it can get. So by doing this, I find out when its a sequence is needed, where more pragmatic and deep complex network is there, you need this RNN to understand. You need the memory element to get a better result. Otherwise, just with the CNN, you can find the linguistic features, but not too much depth. Even if you try it with 10 layers of CNN, but still, no better result we got. Now, this is the last, which is actually, we started to think now. Now, this is a Blade Runner 2049, so there's a line that what it means to be alive by a robot. So there are, right now, we have a small robot, now robot, in our lab, which we're gonna demonstrate soon. I think I'm gonna post a link in my slides later on. So we're gonna talk about embodied storytelling. Now there's one feature we find out while we're doing this. It's not only human who should be monitored, it also should be a robot who should be monitored. We think about robot to be our friend, but it's time to actually think them as a friend, so that we also need to do this offensive content or this move detection on robots. Otherwise, we can never accept them as a friend or as a partner or whatsoever. Thank you.
So does anybody have any questions? We have a bit of a mic. Anybody want to take it? Yeah?
Okay. So did you have only textual data, or you actually had tweets there in your dataset? Then why didn't you use, why did you stick yourself onto text? Because let's say if there's a tweet saying, oh, you're such an asshole, and it has like 1,000 likes, that hurts more probably, right? When, and if it's, yeah, and there is another thing that if it's somebody I don't know, I just say back, no, you are an asshole. I mean, I don't know, but if it's my friend, or moreover my mom says that, I would be really hurt, right?
Okay, good point. There's a few things first is, should we wait for 1,000 likes to know it's offensive?
No, but if you got it, you know for
true.
sure.
I can use that as a training set, but actually in a real life case, it's not wait for 1,000 likes to know that's an offensive. So I just have to be on the fly. And the second one, if I can get the relationship from Twitter, of course I'm going to use it. Just to know how I can know the relationship. Maybe I can have to make another model to find a blood relationship on Twitter.
Yeah, maybe I have history. I don't know.
Well, that's a good point. That's a good point.
Oh yeah. You can just throw it over. Yeah, go
Recently,
for it.
I learned how to throw a rugby ball. It's like this: you put your leg there, and you.
There you go.
So, say you mentioned that if a parent wants to know what kind of tweets their child is receiving, what should the parent know? Like, it's enough with knowing the Twitter holder of the child, or what should they?
That's all. They just put the Twitter handle. They immediately gonna get the public profile because I cannot access the privacy. I can only access the public. So if I have the public tweet access, immediately I'm gonna get all of the resources and software.
So you base the tweets the child is receiving in terms of mentions, whenever that handler is mentioned.
Have you tried other simpler algorithms like support vector machines just to see how the score differs from your solutions?
Okay. First of all, it was part of the hackathon, so it was deep learning hackathon, so I have to use that. But on the other hand, for sarcasm, yes, I have used it. I have used SVM, I have used free SVM, I have used free CIS, all of them. But in that case, I find out the feature extraction, what we in SVM we did. So it was good. It gave me around, for the system which I had, it gave me around 78, but not more than that. I could not go more than that. But then I tried to do it with LSTM, the bigger model, when I implemented that. That actually went farther. Yep. You can shout.
Oh, okay. So this CNN and RNN usually difficult to train with small data sets. So I'm just curious how you overcome these problems, like overfitting and.
Now here is that I can make a small the split. I try to see how the validation score and this is going down. So if I have a 100K data set, and if I have an embedding size of 300, not totally, because we need a 3 billion data set which Google had, and then we can get. So that's why I stick to 120. Also, there's a one more code we're going to push recently, which actually going to take the Twitter 27 billion tweet word data set, which is the 200 embedding. So we're going to push that back and try to see how much code we get more. So that's another walkaway.
Okay, okay. So you mentioned also this max pooling. So I was just curious if you had to use any other tricks to kind of.
I would love to be honest. Like, there was a 3 member team, and one of my other members suddenly on the first day said, "I'm sick, I'm kind of going to." We were 2 member team, and like, okay, let's go on.
Okay, okay.
Finish that, and finally we got it done.
Okay, no further questions. Let's thank Annie again for his great talk.